So, we can see that once again if you look at the expression for the fuel flow rate, it depends on the density of fuel by and large fixed, the area of the fuel discharge nozzle at the tip which is also fixed once we fix a carburetor, H is fixed right by carburetor design, P1 is what we get and coefficient of discharge is what we determine right by experimental calibration. So, once again what can be varied to vary the mass fluid of fuel? P2 right. So, we can see that the mass fluid of fuel is influenced by P1 minus P2. So, interestingly if we do not make P1 minus P2 to be greater than rho FGH, you can see that there is no fuel flow rate right, because if you look at the square root term we see that there is a P1 minus P2 by rho F minus GH okay, taking 2 common from those 2 terms. Okay. So, we can observe immediately that if P1 minus P2 is less than rho F GH, then there is no fuel flow. So, in other words we need to decrease the value of P2 for the fuel to start flowing right. So, that is something which we need to observe. So, as the air flow also increases, okay, let us say we will come to the choke valve shortly, but let us say I give more throttle and the air flow starts increasing. Okay. So, then what will happen? P1 minus P2 will start to increase because as we just discussed, as we keep on increasing throttle the pressure at the throat will start decreasing right. So, P1 minus P2 will start increasing for the same P1 right. So, once P1 minus P2 starts increasing and when P1 minus P2 becomes greater than rho F GH, fuel flow starts. Okay. So, that is the first observation. Okay. So, I hope this is clear to everyone right. So, when we want a rich mixture right during idling, how do we get that? Because during idling the throttle valve is almost closed, the value of P2 is anyway not that low, P1 minus P2 is not that low right. Then how do we get a rich fuel air mixture okay, to idle and also to start the engine. Okay. So, we will discuss that point shortly. Okay. Then we can immediately observe that a decrease in density of air reduces the air fuel ratio, because if you divide the mass fluid of air by mass fluid of fuel we are going to get the air fuel ratio right. So, if we have a lower density of air, the air fuel ratio will decrease. So, the mixture will become richer right, because if the air fuel ratio drops that means we are going to have a richer mixture right. So, this when does this happen? This happens at higher air flow rates where P1 minus P2 is higher, and since the pressure at point 2 decreases, what can we say about the density of air at the throat? That also falls down right. So, and rho A2 decreases. Okay. So, that is one thing okay, which we need to observe, because as we go to this power range, right, we need a richer fuel air mixture, right, is it not? So, as we go to the power range with increasing throttle, we can immediately observe that the pressure drop is going to be higher and density of air is also going to be lower. So, as a result the mixture will become richer. Okay. So, that is an observation, okay, that we can make. Okay. So, now what happens when we do what is called as cold start, right. So, here, so the role of the throttle valve, I hope it is now clear, okay, that when the choke valve is fully open, the throttle valve helps us to regulate the value of P2, so that we can adjust the air flow rate and the fuel flow rate. Okay. So, that is the purpose, right, because as we keep on opening the throttle valve, the air flow rate will start to increase, because more area is going to be now connected to the cylinder which is being subjected to the suction pressure, right, is it not? When the intake valve is open, we are going to connect the carburetor to the combustion chamber, and that is essentially at a lower pressure, right, during the suction stroke. So, as we keep on opening the throttle valve, the air flow rate will increase, the pressure at the throat will decrease, right. As a result the fuel flow rate also will start. Okay. So, the role of the throttle valve is now clear. Now, what is the role of the choke valve? Okay. So, let us discuss that. So, and I hope it is also clear how we get a richer fuel air mixture when we want what to say to go to the power range, right, as we keep on increasing, right. So, you see that it essentially the P1 minus P2 keeps on increasing, right, as we increase the throttle valve opening towards the end, P1 minus P2 increases, rho A2 decreases. So, the ratio becomes, the mixture becomes richer. Okay. So, that is what happens. Now, what happens when we want to start? Okay. So, typically in vehicles with a carburetor, right. So, let us say you want to start the vehicle on a cold morning, right, after you have parked the vehicle overnight. Okay. So, today carburetors are there in certain class of two wheelers, right. So, what do we do if the vehicle does not start? We engage the choke valve. Okay. So, what do we do then? Okay. So, let us look at the function of a choke. So, by default this choke valve is in this position. Okay. It essentially offers the least resistance to the airflow path, okay, at the upstream section of the carburetor. Suppose let us say we want to do what is called as cold start, right, that is like let us say we want to start the engine after it has been at rest for a long time, right, or under cold weather conditions and so on. So, what we do is that we engage the choke, and what happens to the choke? This goes and restricts the path. Once we restrict the path, what is going to happen? We are going to restrict the flow of air, right, is it not? Correct. So, anyway the venturi throat will be at some pressure, but we observe that the channel for the flow of air is now restricted. So, what can you say about the mass flow rate of air? Mass flow rate was density times the area times the speed. Okay. Speed depends on the pressure drop, that is we all of us agree. But now once we apply the choke, the area through which the air flows is now reduced. So, what can we say about the flow rate of air? It reduces, right. Now, the pressure at the venturi anyway drops. So, the fuel essentially gets discharged through the fuel discharge nozzle, and that is affected only by the pressure drop and the area of the fuel discharge nozzle, right, is it not? Okay. Then what can we say about the mixture? Is it going to be becoming progressively richer? Yes, and that is what we figured out that we require during idling, right. When we discussed about the mixture requirements for idling, right. We figured out that during idling we require a rich mixture because the challenge was, see during idling what happens, the throttle valve is almost closed, right, there is a very small opening. So the main challenge was exhaust gas dilution, right, because the exhaust gases mix with incoming fresh charge and that impedes the combustion process, the sustainability of the combustion process. Okay. So what happens is that we essentially want to ensure that when we want to start, we give a richer fuel air mixture, okay, to enable the combustion process to start. Okay. So this choke valve helps in making the fuel air mixture richer, and there is also an what is called as an idling adjustment. Okay, an idling adjustment, okay, which is also part of a carburetor but not shown in the schematic, would also ensure that a richer mixture is provided when the engine is under idling condition. So the role of choke valve essentially is to enable the initiation of combustion during cold start conditions when we want to provide a richer fuel air mixture. Okay, that is point number 1. And during idling we want a richer mixture, and that is provided for by what is called as an idling adjustment mechanism. Okay. So those are systems that we have in a typical carburetor. So let me write down the main points as far as the choke valve is concerned. Okay. So under cold start conditions, it is difficult to vaporize the fuel, right. Cold start means, you know, like that means the engine is cold, okay, and also the maybe the ambient is also cool, right. So it is difficult to vaporize the fuel to form a combustible mixture and hence a rich mixture is required. So we require a rich mixture with the hope that at least a significant part would get vaporized and initiate the combustion. Okay. So the probability of combustion is increased. Okay. So a rich mixture is required. So when the choke valve is closed, a large pressure drop, a comparatively large pressure drop than when it is open, okay, occurs at the venturi throat. And hence a larger amount of fuel is discharged, is introduced through the fuel discharge nozzle. Okay. And this along with the constriction to the airflow, right, makes a fuel air mixture richer. Okay. Thus a richer fuel air mixture is obtained. Okay. So that is what happens with this choke valve. And please note, during idling also we need a richer fuel air mixture, right, as we discussed. Choke valve, the main purpose is to help with cold start. Okay. So with idling we have a richer fuel air mixture because there is something called an idling compensating mechanism, which has not been shown in that schematic, but there is a mechanism for compensating for the for the provision of a richer fuel air mixture during the idling process, okay, in a carburetor. So, but this is the role of the choke valve, okay. So, we can enable a rich fuel air mixture during cold start, okay. So, that is a broad analysis of a simple carburetor, okay. So, we have just looked at what factors affect the mass flow of air and mass flow of fuel in it, and how the fuel air ratio or the air fuel ratio becomes adjusted once we adjust the value of P2, right, and the role of the throttle valve and the choke valve, okay, in its functioning. So, now the next topic which I am going to start in this class and then we will continue in the next class is also like very important as far as engines are concerned, and that deals with engine emissions, right. So, if we look at emissions, right, today like it has become pretty important, and in India we follow what is called as a Bharat stage emission norms, right, for automotive emissions, road vehicle emissions, right. So, right now we are in what is called as Bharat stage 4 and we are directly going to Bharat stage 6 by next year, okay. So, essentially emissions are of serious concern, and the norms are becoming stricter and stricter, and traditionally like the Bharat stage emission norms are also motivated from the European emission norms, what are called as the Euro norms, right. So, what constitutes these emissions, like what effects do they have from scientific perspective on the engine performance, and how the engine characteristics and operating conditions affect these emissions are a few topics that we are going to discuss, and what are the solutions available, right. So, and what are the trade-offs due to the application of those solutions, like in a broad nutshell that is what we are going to discuss in this topic, okay. So, if we look at emissions per se, we can broadly divide them into what are called as exhaust emissions, okay. So, what we call as tailpipe emissions. So, these are let into the atmosphere through the tailpipe, right, of the exhaust system. Then we have what are also called as non-exhaust emissions. So, what are these? So, what come under both categories? So, tailpipe emissions like happen due to the combustion process that takes place in the combustion chamber, and due to the chemical reactions of the hydrocarbons present in the fuel with oxygen, okay. But more importantly, please note that the fuel also contains some other compounds such as sulfur, okay. The fuel is a hydrocarbon, it contains carbon and hydrogen, air contains oxygen and nitrogen. So, we are going to have different combinations of these elements, right. So, ideally if a combustion process is ideal, all the hydrocarbons in the fuel must be oxidized into CO2 and H2O, okay. So, that is the ideal combustion process, but that does not take place. So, what are all the emissions that come about and which impact the our environment? So, sometimes the hydrocarbon present in the fuel will come out unburnt, there is a chance, okay. So, they do not a part of it may not get oxidized, okay. So, we get unburnt hydrocarbons, we get oxides of carbon, okay, CO2. CO2 is a byproduct if we have good combustion. Partial oxidation we get carbon monoxide, okay. So, these are the oxides of carbon, and then we have oxides of nitrogen. So, typically nitrogen gets oxidized at high temperatures, okay. So, we get NO and NO2 as oxides of nitrogen in the exhaust. There can be oxides of sulfur because sulfur if present in the fuel also gets oxidized as SO2 and SO3, and then like we have carbon particles which come out as particulates, soot, smoke. Okay. This last aspect is mainly in CI engines, okay, compression ignition or diesel engines, this last emission, okay, that is emissions where we get particulates, soot, smoke and so on, right. I am sure you would have seen in buses and trucks when they start from rest, right. So, you would see black smoke coming out of the tailpipes, right. So, we will discuss what that is, right. So, and then how do we eliminate them. So, non-exhaust emissions particularly are unburnt hydrocarbons, that is the fuel which escapes without getting what to say combusted. So, we can have evaporative losses in fuel tank, okay. If you use a carburetor, there are evaporative losses in a carburetor, etc. Okay. So, we can have the fuel evaporating, okay, let us say, because, and then that is a loss, right. So, then we can have what is called also as crankcase blow by. So, what is this crankcase blow by? That means that in the what to say, although we introduce the fuel in the combustion chamber, there are always small crevices between the compression rings, oil rings and the cylinder, okay, and some unburned fuel vapor may escape through that small crevices, they can come into the crankcase and escape, okay, that is what is called as crankcase blow by, okay, and that is also an exhaust, right. So, it is a loss of fuel, but more importantly it is an unburnt hydrocarbon, okay. So, these are non-exhaust emissions, okay. So, in the next class what we are going to do is that like we are going to discuss each aspect of this emissions in greater detail, and we will see how they affect engine performance and how engine operation is also affecting these emissions, okay. So, that is something which we will continue in the next class. Thank you.